dry port, which will operate same like the Dar-es-Salaam port here. They will have all the facility, the custom, and of course, the landlord countries, they will have their own custom facility there. If they manage to clear their facilities, eventually there's no need for the cargo to go to the dry port. We'll take the cargo straight away to Kapirimposhi. Kapirimposhi will join to Tanzania to Lubumbashi. This is our mission, and I am sure getting this access to operate through Tazara definitely is a milestone for the economy of the other countries. So let me rest assured, by a simple calculation, as my colleague has been presenting, the dry port is the only saving for any landlord country, but not the portway itself. The port is not supposed to do conservation. The port is there to receive, discharge, loading, and go. Eventually, we have a lot of ships come here. You know very well why other ship owners they are running out of Dar-es-Salaam port. It's because of all this kind of congestion, leave alone some other issues. Of course, with this project, everything will be okay. And that's why I'm here today.
Thank you, Chair. Just to bring you back a little bit to the first presentation, although I think at that time I wanted to add to the second presentation so that we have a clear understanding. I would just like to find out if you already have the estimates on the cost on the proposed dry port. This has to do with the infrastructure. I'm talking about the trucks, what it is going to cost for putting up the dry port. We're talking about the trucks, we're talking about the handling facilities, the basic infrastructure that needs the dry port. We are also aware that as we connect to Tazara, your 3 kilometers stretch, you need those compounds and position of land. Yeah, so taking care of that, have you estimated how much it cost you to put up a dry port, or you are waiting for the market to do that?
Actively, and I please answer the question very, very precisely. Masindiko company, through the very good finance inherent, we've set aside for $220 million for this project, for this particular dry port. And that's how I'm proud with my team. It's going to be an international inland terminal, not only for Tanzania, neither for Africa, but worldwide. It will be. The fund is there. We have all the logistics, and of course, equipment will come up when we are going to the detailed business plan. At this time, I cannot say we are going to put this so, let's say, rubber type cranes or whatever. It's too early. Our prayer to Tazara is to Tazara to understand the equipment we are going to bring in and to say they are ready to operate. And of course, as I said, we're not going to compete with Tazara. We're the supplement to Tazara. Ongoing, we'll be going to address some logistics, some agreements with Tazara. How about we are going to operate? Not at this time. At this time, it's just Tazara to have in mind when we are going to put our proposal to address itself by knowing that Masindiko company is having a willing team which have appeared before the team so that this proposal can be addressed by Tazara independently. rather than voting the proposal and then you come up with the team, it is a vice versa. It won't work. So I am glad and I wish and I still pray. Let's pray our patriotism. This project takeoff, Tazara, will also be very, very good. This issue of unrest is no longer going to happen. Particularly unrest of the industrial issues is no longer going to happen, I can assure you. We have the fund, and as I said, if you are going to get, let's say, a day, $29,000 US in your account outright, what else Tazara is going to pay? Take my assurance, if not going, I'm going for the bullet. But if you're ready, give me the way.
Thank you very much.
Thank you, Presenter. May I get maybe the information if you did any costing analysis on how much it costs to transport the cargo from Dar es Salaam port to Mbeya by train. Maybe if you had done simple calculations using our tariff, then come up with the figure how much it costs for a block train, then how much you can realize as profit out of that cost. So, because we are discussing here the facts, this is going to come in reality. So, setting aside funds for establishing the dry port, that is something else, because that is just a fixed cost. You just pump there, you establish your dry port. Then this one is the running cost, which you have to incur all the time when you are running your train. So, have you done the cost analysis to establish if you are going to come up with a profit margin out of the total cost which will be required to incur all the time when you are making that transportation? This is very crucial because we are in this business. Give us your analysis. Maybe we can see a bright future ahead from what you are to analyze.
Let me answer the question very simply. A businessman has his own methodology of doing business. For information, gentlemen, I've been in the railway industry for 40 years. I know the industry. I know it very well. I know about the shipping line. I know about the inland transportation, how it works. So, our decision of the company to inject this funding to the dry port, to the locomotive, and of course, we are going also to Bay 13 and 14. It is after we have extensively carried out the research. Now, when we are going to submit the proposal, discussing it on the table, if there is any loss, it will be a consequence of our own. But we are not expecting to get any loss out of this business. We have carried out all the survey in DRC, Malawi, Zambia, and recently my team was in Zimbabwe, partly South Africa as well, carrying some analysis on the requirement, including the local freight statistics. Let me tell you one thing. When we are actually thinking about Makapa railway station, there's the iron ore which is being transported. The iron ore is highly demanded in India, so say India is very needed, in China as well. But if you consider to take the road, surely no one will buy it. We were trained, and as demonstrated by my engineer here, we are ready to meet the target. Let me rest you assured, we have already done all this is in our brain, and we are not going to suffer anymore. The second thing is the management part of which Masindiko company is not going to do the management. We are going to give the management to the team. Our role is to set the infrastructure, to finance the infrastructure facilities. We put the team, and to rest you assured of the question which you ask ahead before introducing the gentleman who is going to play upon the system. We are full equipped, 100% equipped for this project. Why we are saying we are 100%? Because I've already established a team which is going to work on this project, not for 1 year or 2 years. It's going to be a long-term contract management of each event. We welcome as well with Tazara during the operations. We put together, we can share technology, and that is my vision as well. We are not going to be selfish. If Mr. Michael Bus is here with the team, we still can share because that is our obligation. Our obligation is not going to compete with Tazara. It's to go, we are coming as a supplement to the Tazara operation. If Tazara had enough capacity or availability of Locomotive, wagon and everything, why should we pay money? When you consider about investing about $420 million for purchasing Locomotive and rolling stock, of which my country, but not me as a businessman, I say, on which my country, which is also a shareholder in Tazara, they cannot support through their budget. We cannot. It's by this method of investment which will manage the Tazara to survive, to operate. At the same time, the government will get revenue. Tazara will get revenue as well. And for the second thing is the management part of which Masindiko company is not going to do the management. We are going to give the management to the team. Our role is to set the infrastructure, to finance the infrastructure facilities. We put the team, and to rest you assured of the question which you ask ahead before introducing the gentleman who is going to play upon the system. We are full equipped, 100% equipped for this project. Why we are saying we are 100%? Because I've already established a team which is going to work on this project, not for 1 year or 2 years. It's going to be a long-term contract management of each event. We welcome as well with Tazara during the operations. We put together, we can share technology, and that is my vision as well. We are not going to be selfish. If Mr. Michael Bus is here with the team, we still can share because that is our obligation. Our obligation is not going to compete with Tazara. It's to go, we are coming as a supplement to the Tazara operation. If Tazara had enough capacity or availability of Locomotive, wagon and everything, why should we pay money? When you consider about investing about $420 million for purchasing Locomotive and rolling stock, of which my country, but not me as a businessman, I say, on which my country, which is also a shareholder in Tazara, they cannot support through their budget. We cannot. It's by this method of investment which will manage Tazara to survive, to operate. At the same time, the government will get revenue. Tazara will get revenue as well. And for
that's a 3-gen set, and that's about it. So that was for the product and NRE. If you have any questions.
Management, Tazara team, feel very free to ask any question, because this is the only opportunity for Masindiko company to come up to say this is what we are going to do. Tazara. Please, welcome.
Thank you, MD, and the presenter for a good presentation. I am not an engineer, but I know the engineer will ask him more questions concerning the presentation. But mine, I just wanted to be given clarification. Considering the reign of Tazara, whereby in actual sense we are getting a loss because of using two locomotives, especially the distance between Mlimba and Chos, whereby if we move one train with 22 wagons from Dar es Salaam to Mlimba, upon arrival to Mlimba, we are now supposed to couple the second locomotive in order to pull the same weight of loco, which is giving us a lot of cost in terms of operational cost, and indeed it also increased the rate of our customers in terms of running their cargo, costing the cargo. So the presenter has shown that this type of locomotive, I'm not sure, I was not proper that if this the same one locomotive can be able to create the same weight from here up to Kapili, now we are not going to use the two locomotive. That's a clarification.
That's a question. It's a question that has two sides. On one hand, what the locomotive can pull is not only limited to the power or the tractive effort of the locomotive, but it's also the line profile, meaning how is the line not just conditioned, but you have slopes and curves. But yes, I'm sorry, that's fine. So in general, but I want to give you an idea, and I know more or less the characteristic of where you were. A locomotive like this can pull anywhere, depending on the line profile, between, let's say, the low end and 1,900 tons to 2,200 tons. You have your wagons here on average, I believe, 50, 60 ton. I mean, so again, you can make the calculation. Now, if there is high gradient at some point, that's where it comes with the increased tractive effort. Of course, there is a limit to any locomotive you will do, but if you're telling me whatever your current locomotive does, I can assure you that this one will do the same or more. And I'm not being here vague. You would have to see the terrain, the gradient. For example, we have in Kenya, we have the harshest portion of 140 kilometers from Magadi to Kajiado, where it is 2.8% and many curves. And we're pulling, not exactly the same, but we're pulling with one locomotive, in this case 1,800 tons, but then after they go to 2,200 tons. So, and of course here, if you, depending on the siding that you have, if you couple more locomotives, if you do MUs, you you increase your capability, but that depends on the line.
The maximum power which you are doing, which you are producing.
On this locomotive, the exact M1 is 2,400 gross horsepower. But because of what I displayed earlier with the traction system having the choppers, it's equivalent to a 3,000, 3,200 horsepower locomotive. Side by side, under the same condition, it will pull the same as a 3,000 plus horsepower. But yeah, each engine, each genset is 800 gross horsepower.
Okay. Then for that case, because our conventional engine, single engine, we are using 3,000 horsepower. So even if I get this one, well, it will give me some advantage when I'm operating with a low tonnage.
Lower load, yeah.
Yes, but maximum power which I will expect to get from it should be the same, like the one which I'm having. Now, just making follow-up from what I've been asked with the acting GMD, is that is it possible for us to use just a single locomotive to pull like what we are doing, MU, multiple unit in some of our terrain? So it means we will still need 2 locomotives in order to, because one locomotive is 3,000 horsepower. So it's just the same as what you are supplying. So it will still necessitate us to have 2, unless you are producing bigger engines with a bigger horsepower, more than 3,000 horsepower.
No, here, first of all, you have to know that you could put a 5,000 horsepower on your line, but what is the limit? It's not the horsepower. Horsepower is for speed only. The limitation on your gauge at the moment is the traction motor. With our traction motor, we can go to a maximum of 750 amps. So horsepower, really, in a sense, you can have many thousands, but you will be just spending fuel and having a big engine, and maybe you will not be able to reach limits of weight maximum. So to be very clear, this locomotive is 2,400 gross horsepower, but where is the advantage? It will do the same, minimum the same as a 3,000 horsepower, but where is the advantage also is that in one locomotive you have 2. Just remember this, that you can do shunting with it, and also I can guarantee you, if we would take a download today of a typical run, if you would give me, we would make a simulation and we could do that for you. You will see that the time that your big engine is working in lower notch, 4 notch, notch 4, notch 3, maybe idle. So here, again, you're spending fuel and you are, wear and tear on a larger cost, because also the moment on a conventional locomotive, if you have a power assembly that blew up, you're down, you can't move. Here, even with lower horsepower, you may not get the speed that you want, but you will get out, and that's very important for railroad. Now, if you still have the availability, the possibility to MU, to make multiple units, if your siding is long enough, put more load. If not, you could stay with 1, but the flexibility, especially for this project, for that you go from the port to your yard, this is where the advantage that, remember, and it's true, it's real, you have literally 2 locomotives in 1, and the fuel saving.
Yeah, thank you. On top of that one is well answered. On top of that, you have given us, I accept, the technology, the design is classic, nice, but you have just given us on the good, only on the advantageous side. You have elaborated almost all good part of this type of locomotive. You haven't given us the main challenge.
The main challenge, and I will tell you without hiding it.
Yes.
The main challenge is you, meaning when I say you, not you personally, us as people. When I introduce this locomotive in different places, you go to the shop floor, the technician, and I was a technician myself, I say, whoa, why would I need 3 engines when I have just one? Why, do I triple my problems? No. The challenge, and I will not hide it to you, and it's probably the biggest, is the mind change. This is it. All other than that, I guarantee, and it's not a sales speech. I can take you to a small operation, but in Senegal, where there's a mining company that started from zero, no shop, no experienced people, only one guy from Senegalese Railway, and you see the tonnage that they do. So, but it was there, the advantage was that you started on a clean page of paper. Now, the challenge, and again, the inconvenience where probably we will have to work hard, is to convince your people on the floor to have a mind change. And that, how do I plan to achieve it? Listen, it's building confidence. If, let's say this project is accepted, we won't leave you alone. We will put the resource during the delivery of the locomotive. It's not just, here are the locomotive and goodbye. We will walk with you. I mean, there is, the mind change, the mindset is the biggest challenge. And I'm not saying that I will succeed here. It might be a stumbling block. But at least, why we can offer a conventional locomotive. We can do that. Typical to GT26, you can go to next door. But here, in this operation, man, the saving is huge, and especially doing when you go to the port and then you go to offload wagon someplace and do the shunting. I'm telling you, the game is there.
Thank you very much. Supply those type of locomotives to country like East Africa.
Well, no, East Africa, no. We have in Senegal, we have in Congo, we had, but it was through a private company, a private mining company that closed. So the locomotive have returned to South Africa. But the best example, but in a smaller case, and we're discussing more locomotive, it's a much smaller operation, but the best example I can give is Senegal. Very bad infrastructure, meter gauge, 18 ton per axle, port, there is a disaster, and they have 95% availability.
Yeah. My concern is that the main challenge, especially we, Tazara, which we have been facing, the operation of these locomotives, you find the traveling portion of the locomotive is the underpart, meaning the combos, the traction motors. Yes. That has been a very serious problem. Now, after research, the issue seems to be lying on the type of what we call insulation of these traction motors. Now, have you ever designed locomotives to work in the conditions whereby you have in one part like a summer or hot season, hot atmosphere throughout the year, and the other part of the line is almost very cold. So your locomotive is subjected in two conditions. It starts from hot condition, then suddenly it finds itself in a very cold condition. So how do you mitigate that?
So, very short answer. First of all, yes. The traction motor that will be here in this locomotive is the 761, the GE, but we reversed engineering about it. There are two aspects that you will be very familiar with.
Yeah.
The traction motor is a 761, but made by NRE, and we increased the mass of copper, and it goes to 750 amps. Just on this trip, I got an order in Tunisia for 100 traction motors. We have thousands of these traction motors working in this type of climate. The closest and the harshest condition is really Kenya. I come back to again the operation of used to be Magadi Soda Company, that you will see. The bogie is the same. We bought the rights for it and made some modification. It's the same bogie that you had on your, I don't know if it's class 94, that used to be from MLW, Bombardier, GE. It's a cast. I think that's, so it's a Dofasco originally, but now we do it. It's a very simple but very rugged bogie. And the traction motor are beefed up to take more abuse on the dynamic vibration, the temperature, the change in temperature and high humidity, as well as the load. So I'm very confident, and this can be verified.
Yeah, thank you very much. I think it will be proven, especially on those traction motors. We are very much concerned.
Yes, yes.
Maybe, sorry. Maybe one question. Two. From your presentation, I noted that when presenting the locomotive to us, you emphasized the point on the make of the locomotive, where you are saying it's modular, it's easy to maintain. And I just wanted to find out from you on this, is it more of electrical and electronics than the mechanical side?
There is more electronic.
Yes.
Yeah. Well, listen, today, even when you buy a car, the minimum, you have to have some electronic. Here, you have electronics. It's gone are the days from the older locomotive, which you have these big modules, the E-card or some of these big modules. Everything is compact. Yes, there is electronic, but it's well proven, it's easy to use, and it does not require any special care. Today, without a microprocessor, which is a computer basically, that's what you have on the locomotive. So as electronic, you have a microprocessor, you have an event recorder for what used to call the dead man system. So all this is incorporated, but it's so compact, and it's either working or not working. But it is also with our microprocessor called the N-ViroMotive, you have a very easy access to a download that gives you. There are 3 downloads, but you can use one for troubleshooting, which really gives you second by second what is happening to the locomotive. Of course, it requires some training. I'm not saying that here you go and you do, but it's accessible, as well as data that will tell you exactly how you are using your locomotive. So,
yes, I was asking that in respect aspect of the maintenance part after, and the parts that we need to use.
Maintenance, I would say, for the electronic, as long as you keep the cabinets closed and they are ventilated, there is no reason to, if you take your old GE or the old locomotive where you had cabinets that are not sealed, that's where the big problem. These cabinets are sealed, they are ventilated, they can, if they work in Magadi, which is really, it's like I call it Magadi in the hot, Magadi Valley. It gets to 40, 45 degrees Celsius. That's the hottest reference. So it is reliable.
Thank you very much. I just also wanted to have a follow-up question. I want to know if you have supplied some of these locomotives to Senegal. I wanted to find out the numbers, and then also I wanted to find out on the human capacity, how have you approached, because you see, you may be going to a railway where there are different technology, and sometimes different locomotives, type of locomotives, and sometimes it's difficult to maintain 4 or 5 types of locomotives, right? One. So I just wanted to find out on the training aspects and the human capacity.
I will tell you that for this operation in Senegal, and you can Google it, it's GCO, the company, the mining company. It was at the same time a challenge, but there is also, if you hear some number, you might say it's not comparable, but it is comparable because it started from day one, an operation that from day one had no workshop, nobody, only 2 people that they took from ex-Senegal Railways, an electrical supervisor, an electrical engineer, and a mechanical engineer. So the locomotive or the fleet is only 5, but the challenge there is that there was nothing. And the training itself, so first of all, during the construction, they came to visit. When we did the commissioning, we were there, and we did extended period of presence. Now, for example, where it may not be comparable, let's say a project like this would happen here, and just to be very conservative, let's say 20 locomotives, that's a fleet of 20. We would make it that there is, during the whole warranty period, to have somebody here, and the transfer of technology will be, the training will be gradual this whole period. This locomotive here, we have to say black and white. If you were to buy this locomotive, just not anyone else, without follow-up, without support, it will fail. You cannot have a new type of locomotive and be expected to maintain it, to repair it on your own. So I don't want to take the whole time here, but the support will be from day one.
Thank you. Lastly, maybe I know this question very well, but lastly, what is the average in terms of acquiring one?
Cost?
Yeah.
Listen, very straightforward. There is a market out there. We try to stay for all new locomotive. I will try always to stay under GE and EMD. We cannot compete with the Chinese locomotive. Chinese locomotives are the cheapest in the market. If you're looking for the cost, you go and buy Chinese locomotives. However, you check what happened in Namibia, Zambia, Pakistan, and all. With all due respect. Now, as far as cost, today it's almost a locomotive from GE EMD is roughly $3.5 million, 3.2 to 3.5. The European are that million, 3.5 or 4, but in euros, and we try to stay at the level of 3 3.1, depending on the number of locomotives we can play on. But the number, if you look at that presentation that I put in 2014, it's still the same.
May I invite you to save time, we'll be saving those who would like to make a cup of tea. Everything is set up there, you can just go and make a cup of tea and come back. Okay. We will not break off for tea.
As to, okay, you are saying your motive, okay, it's 2 in 1 compared to ours, where you are saying this is conventional. Okay, my question is that in case of a total failure of one engine, or either by damage, whatever the case, because I know this locomotive, they share some control systems, although it's just 2 engines. Is it possible now to do with hand engines? Okay, either by just taking half of the load from, or it's either the driver is stuck in the bush. Is it possible to cut the load, then you pull half of the load to another station, then the driver may go and back and pick another half of the load? Because you can see in case of a locomotive, in case of any failure, that means you have to take another locomotive from any nearest point to go and do a rescue. So I just want to know if that locomotive has got that advantage here.
Yeah, here the advantage.
Thank you very much for that presentation. We need to consider the advantages of the manufacture, especially also with the interest in the fuel management systems, and also so that we are able to tell exactly where it is, but not easy.
Thank you very much, Acting MD. Again, I'm still here in my team. Wish to welcome Mr. Wangwe to make the presentation.
Good morning, ladies and gentlemen. I'm Mr. Gao from Baotu Beifang Chuangye Company Limited, who is manufacturing of rolling stocks in China. And 40 years ago, the Chinese people they came here to build the railways between Tanzania and Zambia. Now today, we came here to present our own products to our old friends. So today, my presentation is divided into 3 parts. The first part is a short video to show you our company's capability and the products.
Support NRE and Rolling, first machinery group company limited. Locomotive, flat wagon, covered wagon, hopper wagon, and special wagon. Making the company realize serialized, scale-oriented, and professionalized production, and fully meet the market demands in railway transport equipment industry. Processes and vehicles in order to improve this equipment production and all better and boost the product market. Today the company is including domestic defense production lines like body assembly line, wheel set processing and assembly line, body assembly line, and complete wagon build line and assembly line. It is realized automatic inspection, data sharing, and throttling test using dimensions of the axle. The axle production process management and leading efficiency. Beifeng Chuangya made full use of listed companies' financing platform and has invested 1 billion RMB to complete a construction project for upgrading heavy load and high-speed technology for railway wagons. Widely application of informatization technology measures makes Beifeng Chuangya become a production base for railway wagons on the international defense level, as well as an R&D and test base on the national first-class level.
For Tanzania railway project. So in this part, I will divide it into 4 sections. The first one is a project journal. Baotou Beifang Chuangye Company Limited, which is short for BSCY, got inquiries information in 2015 for the procurement of the railway wagons, and at that time we submit our own proposals. And then in 2017 we received the updated technology specifications, and we made also the preliminary proposals for this project. This new proposal was made strictly as per the customer's requirements and based on our advanced scientific method, successful design, and manufacturing experience for more than 30 years. Because BSCY was founded in 1984, till now we have more than 33 years experience in design and manufacturing the railway wagons. Here is the updated technical specifications we received. Now the second part is a capability to guarantee how we can fulfill this project very well. The first one is R&D capabilities. In BSCY, our R&D center has 124 employees, and among them, we got 6 professors, senior engineers, and 27 senior engineers and 55 engineers. They have the enough capability to guarantee we design and manufacture the best quality products. Here is office for the R&D center, and our engineers is designing the wagons. So besides we got a lot of senior engineers, we also have advanced R&D method. You see, the R&D method, we got 2 parts. The first one is product design. Recently, we have 2 methods to design wagons. The first one, we use 2D or 3D. And the second, will be proven by the 3D Pro Engineer software. After the wagons and the products was designed, we got a lot of method to do the simulations. Here is the software we use to prove and to verify our design was correct and perfect. You see, here we use the ideas and answers, static strength and fatigue strength analysis, and the SIMPAC dynamic performance analysis. And here is ADAMS, mechanism movement simulation analysis, and the fourth is ideas body analysis and calculations.
Besides advanced software, we also got a lot of design. The first one is top to down, accurate 3D design. You see, the bottom, the top is a wagon body, and the bottom is a bogies. We use this kind of design to improve the design qualities of the wagon and shorten the design circles. Besides, we also use a fatigue strength simulation analysis to improve the reliability of the wagons. You see, by using of such kind of software, you will know where the stress is, just to avoid such kind of stress, to improve the quality of the wagons. The third one is a dynamic simulation analysis for the complete wagons to improve the running stability of the wagons. So in our factory, every wagon, after it was designed, we will use all such kind of method to prove and to verify this is a good quality products. And here is some testing equipment of our workshops. The first one is for testing the static strength of the wagon bodies after the wagon was designed and manufactured. It will be done. And here is a test equipment for the brake valves. Brake is the most important part for the wagons. So this one is also very important. Here is a test equipment for the brake shoes and single car brake test, which will be done for every wagon. And the tightness test for the reservoir. This one is also related to the braking systems. The last one is a strength test for the brake beam. It's also for the brake beam. It's also for the brake systems, which show you that the brake system